In this video, we are going to discuss about Beer-Lambert's law. It mainly explains the interaction between light and matter. It's a combination of Beer's law and Lambert's law. First of all, we want to discuss about the Lambert's law. The Lambert's law states that when a monochromatic light passes through a colored solution, the amount of light absorbed is directly proportional to the length or thickness of the solution. For example, this is a solution. When a monochromatic light passes through this solution, some amount of the light is absorbed by the molecules present in the solution and some of them are transmitted. So, the amount of light absorbed is directly proportional to the path length. This is the path length. Path length or thickness of the solution. Path length or thickness of the solution. This is Lambert's law. That is, when a monochromatic light passes through a solution, the amount of light absorbed is directly proportional to the thickness of the solution or the path length of the solution. Now, let us discuss about Beer's law. Lambert's law was extended by Beer, and who showed that when light passes through a solution of a given thickness, the fraction of incident light absorbed is dependent not only on the intensity of the light but also on the concentration of the solution. Suppose when we are passing a monochromatic light through a solution, when we pass a monochromatic light through a solution, the intensity of the absorbed light is dependent not only on the intensity of light but also the concentration of the solution. So that is, the intensity of the incident light absorbed is proportional to the intensity of light and the concentration of the solution. By combining these two laws, that is Beer's law and Lambert's law, we get Beer-Lambert's law. Now we can discuss about Beer-Lambert's law. It states that the amount of energy absorbed or transmitted by a solution is proportional to the concentration of the solute and path length of the light. That is, the amount of energy absorbed or transmitted by a solution is proportional to the concentration of solute and path length of the light. Suppose we have a solution with unknown concentration. This is the solution with unknown concentration. So, to find out the concentration of the solution, we can use the Beer-Lambert's law. So, when we pass a monochromatic light through this solution, some of the light are absorbed by the molecules present in the solution and some of them are transmitted. Here, I0 is the intensity of the incident light. I0 is the intensity of the incident light and I is the intensity of the transmitted light and C is the concentration. C is the concentration of the solution. Here, we can see that when we pass a light through the solution, the intensity of the transmitted light decreases. That is due to the absorption of the light by the molecules present in the solution. So the intensity of the transmitted light is less than that of the incident light. This is due to the absorption of the light by the molecules present in the solution. The relationship between I and I0 depends on the path length L. This is the path length. The relationship between I and I0 depends on the path length. This is the path length. So, the relationship between I and I0 depends on the path length of the medium. and the concentration of the absorbing solution. So the incident light and transmitted light depends on the concentration and path length of the solution. These factors are related in the laws of Beer-Lambert. Now coming to the equation of the Beer-Lambert's law. Beer-Lambert's law is written as A equals epsilon LC. A equals epsilon LC, where A is the measure of absorbance and it has no unit. A is the measure of the absorbance and it has no unit. Epsilon is the molar extinction coefficient. Epsilon is the molar extinction coefficient, or it is also known as molar absorptivity or absorption coefficient. And L is the path length and C is the concentration. L is the path length and C is the concentration of the solution. And the molar extinction coefficient is a constant and it varies for each molecules. And the epsilon has unit liter mole raised to minus 1 cm raised to minus 1. Liter mole raised to minus 1 cm raised to minus 1. The path length is measured in centimeters. The path length is measured in centimeters because we are using a cuvette that is 1 centimeter in width. So, I is always assumed to be equal to 1 centimeter. So, the path length of cuvette is 1 centimeter. So, the Beer-Lambert's law is a linear relationship between the absorbance and the concentration of the sample. It is a linear relationship between the absorbance and concentration of the sample. Now, coming to the application of the Beer-Lambert's law. The Beer-Lambert's law mainly used in calorimeter, spectrophotometer and different spectroscopy techniques. That is, the basic principle of all these techniques are Beer-Lambert's law. This is all about Beer-Lambert's law. Thank you.